The purpose of this video is to show you some cool features that are particularly helpful when sort of planning and evaluating your robot for FTC. So here I have CAD tutorial file design open. Gonna save it really quickly. So I'm in the folder that my team uses to store our FTC inventory of parts. I want to create something, the servo, so I've already typed it in here, but yep. So we search for everything related to servos because I want to build sort of a servo mechanism. So let's see, let's import the high-tech servo into our design. Remember, right-click, insert into current design. I'm good with its location, so I'm just going to hit enter right off the bat, and now it shows up in the browser right here. And next we need a shaft hub, so again right click, insert into current design. I am going to move out this one so that it's not interfering with my view of the servo. And I'm going to rotate it because when you join two pieces in Fusion, actually let's not rotate it yet, I'll demonstrate what I mean. Say I want to join the shaft hub onto the servo. If I click, let's say here, join at the origin, if I click here, it's going to join as it is oriented. So it's going to, because the way I selected the joint was with two parallel circles. However, because of the way that the piece was oriented, it's joined incorrectly. So we're going to hit the escape key because we want to undo that. We don't want that to be saved. And we're going to rotate this component. So remember, if you click on a component, it's not going to highlight the entire thing. So let's say I want to highlight this. When I've clicked on it, you'll see the line shows up. That's a really good way to just quickly identify which piece we're talking about. We're going to click on the item, hit the M key, the shortcut to move. And we are going to turn this 180 degrees. Hit enter. Now we're good. Now when we join them, the pieces together, I'm gonna hit the J, capture position so everything stays as it is. Remember, J is the shortcut for joining. I've selected the center of that piece, and now we're going to join it to this component here. Now as you see, that's correctly on there. What we can actually do now is adjust its location on this joint. So interestingly enough, when you join two pieces, they don't actually have to physically be touching. I could click enter when it's out here and that would work, but we don't want that. Yeah, we're just gonna stick it here for the purposes of the video, but you can adjust this and fine-tune it based on what you want to do. So click enter, and then if I want to move this part, they will move together. We're going to hit escape so that it returns to its location. Okay, so say I want to undo this joint. I'm going to click on this. This is the symbol that pops up when you have a rigid joint specifically. If you can't actually see that, come down to object visibility and you should be able to see joints and joint origins, so make sure that's enabled. If I click on it, it's highlighted blue, also shows up in the timeline. I'm just going to hit the delete key. That joint was deleted, so this returns to where it originally was before I established that joint. So I want to create a joint that actually rotates, because on a real servo, the shaft hub would be able to rotate on the servo. That's how they work. So I'm going to do the same thing, change the view so that I can create a joint. Remember, you can either click join and then select two components, or you can select a component first, then click joint. The key thing here is we've been creating rigid joints so far in this tutorial series, but if you come over to this panel here, if it's minimized, just click the plus button. We're on position. If I move over to the motion tab, I can actually change the type of motion that the joint that results when we put the joint together. So right now we're on the rigid joint type. It locks components together and removes all degrees of freedom, right? So they can't move relative to each other. I want to go over to the revolute, which means the component's going to rotate around the joint origin. That's perfect. Don't want any of these. This means it can slide along an axis. Yep, none of these are sounding like the right things. You can always try them out by yourself, see what they do. But for to get a component to rotate around another component's joint, we're going to click revolute. So now that this is selected for the motion, I'm going to come back over here and we're going to select the component 2 location, and I'm going to go right here. Now we see cool little animation tells you the type of motion. So let's say that's actually not what I wanted to do. I can actually test out the different options here. So you can see this is not correct. Also not correct. Yep, not looking for planar motion. That's a cool one. Rotates around 3 axes. Yeah, we wanted the revolute one. We were right on the first guess. So we're gonna click revolute. Notice how we haven't actually hit the joint, so we can actually hit the escape key at any point and just return it to the right, to its original location. So let's highlight that again. Join. Yep. If we look at it from the front, yeah, it looks good. Purpose of the video, just going to move it down 5 millimeters. And now, if we wanted to simulate the motion of this component, we would actually be able to, because the joint type that we have chosen actually reflects how the how it will move in real life, which is pretty cool. Yeah. So I believe come over to animation. I can leave this for a different time. Sticking with the line. Yeah, I think that should be it for this video. Oh, actually no, let's do one more thing. So one thing that's really helpful with science and math is maybe your engineers have been all over the robot and you're supposed to be figuring out what the center of mass is for your robot. Well, if you've managed to stick to your CAD design more or less as accurately as possible, your CAD design can actually tell you where your center of mass is, where the mass of the entire thing, actually give you a lot of science and math related properties, because the parts that we've downloaded these these step files from has that sort of information, like the mass of the parts. So say I wanted to figure out what the center of mass is of this group. Well, first we need to assemble a rigid group. We're going to make it a rigid group. So we lock the relative position of the selected motions. So now that when we move them, they move as a relative object. So we want them to sort of be in the same size. We're going to create a rigid group. I'm selecting that component. That component. It's going to mess up our joint, but that's okay. So now it's moving as a rigid group. So if I click on the rigid group, so let's say I click on this. Let's find the properties. So this is the properties of the servo shaft tub. So it actually gives us the area, density, mass, volume, the material it's actually going to be at, where your center of mass is, moment of inertia at center of mass. This is all really good, and you can copy it to your clipboard so you can save these values, and you can use it when you're evaluating your robot and considering science and math, so it's super helpful. If I want to figure out the properties of the group as a whole, I believe we can also do that. So if we come to here, the whole thing, if we scroll down to properties, we can get the center of mass of the entire thing. So that's how, when you've built your entire robot, like we have, or here, this is an arm that we used one year. Click on the whole arm. We actually have the properties. Like the mass, we need the mass to figure out the torque of the arm. So this is super, super helpful. And yeah, that's so that's it for this video. Hope you learned something about creating different kinds of joints for FTC parts, and also a cool way to figure out some science and math measurements that can help you in evaluating your robot design. Good luck with your CADing.